Hello students, we were doing BS law in magnetic effects of current. We had done already magnetic field due to circular current at axial point. You know the formula, right? Mu naught I into R square divided by 2 into R square plus X square raised to power 3 by 2. So this we had already done. Now let us move to this one. Magnetic field due to straight current, right? Straight current carrying conductor. Okay. So this is our current carrying conductor. All right. Now you can see that point O and C, O, C are the segment of conductor we have taken of L length. Okay. And what we have done? We have drawn a perpendicular from, so first of all, just ask yourself, where do we need to find out the magnetic field from the straight conductor? Okay, this is the conductor and this is the point where we are interested in finding out the magnetic field. Okay, that is good. Now what you would do, you would draw a perpendicular from this point P to this point, perpendicular to the conductor. Mark this distance to be A. A is perpendicular distance of point from conductor. Okay, this is there. Now, first of all, we recall basic formula of BS law. From BS law, what do we have? dB equals mu naught I dl sin theta by 4 pi r square. Okay. You are aware of this? What is R? R is this OP. R is OP. Okay. And this is theta. R is making some angle with ideal. This is ideal. Okay. This is ideal. That small segment of current element, right? This is current element. This ideal and R is making theta angle with each other. So that is clear. This is BS law. Okay, now what we will do, we will substitute the value of this and this in terms of this angle phi. In terms of this angle phi. What is phi? Phi is the angle made by this perpendicular distance with this R. So this we need to understand very, very, very carefully. Okay. Okay. So in triangle, let us do this. In triangle OCP. Okay. OCP. In triangle OCP. What is this? Theta plus phi equals 90 degree. Okay. So sin theta would be sine of 90 minus phi. If you have this, we can easily say that theta equals 90 minus phi. If theta plus phi is 90 degree, then theta equals 90 minus phi, that we have taken. So sin theta would become what? Sin theta equals cos phi. Okay, this is there. This we will substitute here in the place of sin theta. Why we are making this? Our agenda is to put all the terms dl, sin theta and r in terms of phi. Okay, and further if we will move, this end is making phi 2 angle, this end of the conductor is making phi 1 with this point P. This we need to keep in mind. If the conductor would be longer, this angle would be bigger. You know, if this end is longer, then this angle would be bigger. This is what we need to keep in mind. Okay, now let us move. So again I am drawing it. Let us draw this again. Let us draw this again. So first of all, this is the conductor. We have drawn a perpendicular from this point P. We call this as A, we call this A. Now this is R. Okay, this is theta. This is the direction of current here. Okay, this is L. So let us call this O. This is point P, and this is Q. OPQ, triangle OPQ, and this is L length, entire length. Okay, so this is going to be phi. Okay, and now this triangle, this angle is phi 2. Okay, and this angle, this end is making phi 1. This is phi 1, and this is phi 2. So this we have understood. We have so far done this thing. dB equals mu naught I dl sine theta by mu naught by 4 pi, obviously 4 pi r square. This is what we have. So we have already done sine theta equals cos phi. Sine theta equals cos phi. This, mark this as equation 1. Okay, and in equation 1 we will put this sine theta equals cos phi. Sine theta equals cos phi. Okay, and further let us call this cos phi equals in triangle OPQ. Cos phi equals what? Cos phi equals A by R. Cos phi equals A by R. Okay. So R equals what? A by cos phi. Cos phi. That means R equals A sec phi. A sec phi. Okay. So we have R square equals A square sec square phi. So this is another thing that we require to put here. For dl, for sine theta, and for r square. For these three we need to substitute. So sine theta we have this, for r square we have this. Now we have in this triangle itself, in this triangle, let's take another triangle OPQ. Triangle OPQ. What we have? Tan phi equals L by A. L by A. Tan phi equals L by A. So we have L equals A tan phi. A tan phi. So what we will do? We will differentiate this because we require dl. We require the value of dl. Okay. So dl by d phi equals A sec square phi. A sec square phi. So dl could be written as A sec square phi d phi. So this is another thing. So we have got already sine theta, r square, and dl in terms of phi. This we will substitute in this equation. This one. So let us move further, see what is going to happen. So dB will be mu naught I by 4 pi, okay, this is there. Now for dl sine theta, for dl, what is dl? dl is a sec square phi d phi. A sec square phi d phi into sine phi becomes cos phi divided by r square equals a square sec square phi. So these things were found, okay, in this new expression. After substituting, see what all we have substituted. We have substituted in place of sine theta, we have substituted this cos phi. So here cos phi, for dl we have substituted a sec square phi d phi, okay, and then for r square we have substituted a square plus a square sec square phi. So this is our final result. Now if we will move further, we can have this mu naught upon 4 pi a into sec square phi gets cancelled, this a gets cancelled, so finally we have got mu naught I by 4 pi a into cos phi d phi, okay. So dB comes out to be this. Now integrating this over the limits, mu naught I upon 4 pi a cos phi d phi, and what are the limits? Limits would be minus phi 1 to phi 2. These are the limits, okay. If you can see the diagram, phi 1 and this is phi 2, okay. So if we integrate this over the limits phi 1 and phi 2, we will have this for the entire length of the conductor, okay. So this is the final result. Let us move further. We all are aware as mu naught I upon 4 pi being constant is taken out of this, so cos phi d phi minus phi 1 to phi 2, and finally we get this. Finally we are getting this. B equals mu naught I by 4 pi a into cos phi would become sin phi minus phi 1 to phi 2. So final result would be B equals mu naught I by 4 pi a into sin phi 1 plus sin phi 2. Sin phi 1 plus sin phi 2. This is our result. Okay. This is our final result. So quickly, if we move further, quickly if we can look back and see what all things we have done. We have BS law, okay. In BS law, dl sin theta and r square are expressed in terms of phi. Here you can see, okay, in terms of this phi, you can see here, this in terms of this phi. So how do we do this? We have this triangle, okay, fine. This is r, this is theta, okay, this is L. So in this triangle, if you see, theta plus phi is 90 degree. That is theta we found, and then sin theta would become cos phi. And further, cos phi equals a by r. So r could be written as a sec phi. So r square equals a square sec square phi. Okay. Then we have in the same triangle tan phi equals L by A. Look at it. Tan phi equals L by A. Perpendicular, this is phi, right? L by A, P by B. Okay, so we got this. Tan phi equals L by A, and then L equals A tan phi. we differentiate this because we require dl. So dl with respect to phi will be a sec square phi. So finally we have dl equals a sec square phi d phi. And then what we did, we have substituted all these parameters in this equation. So it comes out to be this. Mu naught I by 4 pi is taken out of this. There is no change for this. So this is for dl, this is for sine theta, and this is for r square. Okay, now the equation appears to be like this. And then we have this final result. Okay, mu naught I by 4 pi a into cos phi d phi. Then we will integrate this because we require to find out the magnetic field due to the entire conductor, not for this particular segment. Not only for this particular segment, we have to get it for the entire length. So that is why we need to get the limits minus phi 1 to plus phi 2. Okay, so we have integrated this, and finally we have this cos phi d phi is coming out to be sin phi plus sin phi. So this is what we have done, minus, and over the limits minus phi 1 to plus phi 2, and then we have done this. This is our final result. Okay, so mu naught I by 4 pi a sin phi 1 plus sin phi 2. So let us put the result here. First of all, let us put the result here. What is the result? B equals mu naught I by 4 pi, mind it, 4 pi a. What is this 4? What is this a? A is the perpendicular distance of point P where we are finding out the magnetic field from the conductor itself. Okay, this into what? Sine of phi 1 plus sine of phi 2. This is the result. Okay, now what is the direction of magnetic field? Okay, this is very interesting. If you have this conductor, if you have the conductor placed on this plane, so magnetic field here would be out of the page and here it would be into the page. As I have told you that magnetic field is found, direction of magnetic field is found using the right hand thumb rule. So if curl of the finger, if current is represented by thumb, then curl of the finger will give us the direction of magnetic field. So if we place it like this, you see here, this is outward, and if it comes here, it is inward. If current is like this, thumb represents the direction of current, then magnetic field is represented by curl of the finger, which is here showing as into the page, right? So this we need to keep in mind. So we have found this point P here in this, so that is why it is going to be into the page. So let us put it here into the page. Okay, now we will do some numericals and some results of this. There are few basic results. From this we need to work out, like suppose this end y is in far away, it is far away, then what? Phi 2 would become 90 degree. In that scenario we have magnitude of magnetic field different. So what is that field? We will work it out. So let us take, we have a magnetic field, magnetic field due to straight line, straight current, you may say. Okay, straight current, as what? B equals mu naught I by 4 pi a into sine phi 1 plus sine phi 2. Okay, so now what? If we have got this result, let us move further to find it out in this manner. For case 1, let us take this case 1. Okay, there are different results. So if phi 1 equals phi 1 equals 90 degree, phi 2 equals 0. Let us talk this. Let us talk about this. So what will happen? If you are saying phi 2 equals 0, that means this end is not there. This end is not there. Okay, it has got only this end. This is 90 degree. That means this is going to be what? This is going to be, this phi 1 is going to be 90 degree. Okay, this is semi. We call it semi-infinite. For semi-infinitely long conductor. So this is going to be what? Put this value here. B is going to be mu naught I upon 4 pi A into sine phi 1 is 90 degree. So sine 90 is 1. Okay, put this here. Sine 90 is 1. 1 plus sine 0 is 0. So final result is going to be mu naught I by 4 pi A. Okay, this we have done. Now again, direction would be that way. Direction this here would be into the page. That is clear. That is not going to change. This side it is into the page. If you take this here, then this is out of the page. That we need to keep in mind. Okay. Now, if you have got infinitely long conductor, it is going to be what? Phi 1 equals 90 degree. Phi 2 also equals 90 degree. Phi 2 also 90 degree. That we can make out, right? These two ends, right? Both the ends are infinitely away from this point. So this is making 90 degree, this is making 90 degree. This is also 90 degree, this is also 90 degree because this is endless. Okay, so in that scenario what will happen? B equals mu naught I by 4 pi A into 1 plus 1, that is B equals mu naught I by 2 pi A, and again this as here it is into the page. Direction will be into the page. So this was the basic idea behind this. Two results, although we have done. There are many questions based on magnetic field due to these straight conductor. We have done circular current. Then there are many different scenarios in which we need to apply this logic. How magnetic field is found using one of the concepts or multiple concepts. At times this is there. This semicircular arc is there, and then this is endless. This is endless. Current is flowing in this manner. So there are various different numericals are asked in JEE, in NEET, in boards. Okay, so we have to practice those questions. In the next segment, we will talk about this only application of BS law, but we will do numerical questions based on this BS law. Okay, so I hope that whatever we have done till now, you have mastered this. Today also what we have done, practice properly. In the next segment, we will have more exciting sessions coming up, because we will do quickly all the applications of whatever concepts we have done.